In Bangladesh, the era of cheap, abundant natural gas is ending. Energy security is no longer just a cost issue, it is a production survival issue. We face two realities: volatile gas prices crushing margins and low pressure halting production lines. Continuing to rely solely on gas boilers for process heat is a strategic risk. Yet, as energy auditors, we see a massive opportunity. Your factory is bleeding heat. ETP discharge water at 45 degrees Celsius. Cooling tower return water at 40 degrees Celsius. This isn't waste, this is free fuel. We propose a hybrid solution. Step 1, the sun. Not PV panels for electricity, but highly efficient solar collectors. These harvest direct thermal energy, heating water to over 70 degrees Celsius even on hazy days. Step 2, waste recovery. We don't put wastewater directly into the heat pump. We pass it through a heat exchanger, safely capturing that valuable 45-degree heat without fouling the delicate equipment. Step 3, the buffer tank. Both the solar heat and the recovered waste heat feed into this massive thermal battery. It stabilizes fluctuations. If the sun hides behind a cloud, the waste heat compensates, ensuring a steady supply. The result is stability. We are no longer asking a heat pump to lift temperature from a cold 25 degrees Celsius. We are delivering a constant, stabilized 50 degrees Celsius input. This is the secret to ultra-high efficiency. Enter the heavy lifter, the industrial high-temperature heat pump. It is built around a robust industrial twin-screw compressor designed specifically for high pressure and high temperature lift. Let's trace the cycle. Stage 1, the evaporator. The 50 degrees Celsius water from our buffer tank circulates here. The special refrigerant absorbs this heat and boils intensely into a vapor. Because the source is hot, the suction pressure remains high, reducing compressor work. Stage 2, compression. The screw rotors trap this vapor and mechanically squeeze it. This massive increase in pressure spikes the temperature rapidly, boosting the gas to over 100 degrees Celsius. Stage 3, the condenser. This superheated gas enters a highly efficient plate heat exchanger. It dumps its thermal load into your fresh process water, instantly heating it to 90 degrees Celsius for production use. Stage 4, the expansion valve. It drops the pressure of the liquid refrigerant, resetting the cycle and getting it ready to absorb more heat from the buffer tank. Where does this massive amount of 90 degrees Celsius water go? First, directly to your dyeing vessels. Bypassing the steam ramp-up phase saves enormous amounts of boiler fuel and shortens batch times. Second, for stenter machines and dryers. We use hot water radiators to preheat the intake air, significantly reducing the load on your gas burners or thermal oil heaters. Third, boiler feed water. Instead of feeding your steam boiler cold water, we feed it 90 degrees Celsius preheated water. This alone can reduce your boiler's gas consumption by 15 to 20% immediately. Let's look at the thermodynamics. A standard heat pump might have a COP of 3, but by using a hybrid solar waste source of 50 degrees Celsius, we achieve a co-op over 5.0. What does COP5 mean? It means for every 1 unit of electricity you buy, you get 5 units of heat energy. Even at industrial electricity rates, the cost per gigajoule of heat is drastically lower than burning gas. For your international buyers, this is crucial. Decarbonization, moving from combustion to electrification, significantly lowers your Scope 1 emissions, boosting your standing as a sustainable supplier. The investment includes the solar collectors, the heat pump, and integration piping. Based on current Bangladesh gas tariffs, the typical return on investment is between 18 to 24 months. After that, the energy is essentially free. This is a low-maintenance, highly reliable utility. No high-pressure steam risks, no boiler operator license required for the heat pump itself. just steady, automated thermal energy. The hybrid solar-assisted heat pump isn't just alternative energy. It is the future of thermal processing in Bangladesh. It turns an environmental liability, waste heat, into your greatest competitive advantage.
Powering sustainable textiles.